Hey, TechKnowStuds! If you're using the Octal numbering system, you're probably using it for some sort of Linux or Unix file permissions. That's more often than not the cases where we have to use this. So in this lesson, let's see how the Octal numbering system applies to Unix permissions. So where would we really see this Octal system? Well, it has to do with permissions and the settings that we have on these permissions. They are flags. So let's first of all talk about what a flag is. A flag is a setting. It's a single bit. It's to turn something on or something off. So a lot of times we associate it with some sort of settings, that we can turn a setting on or off. So here's just an example. Here's just some settings that, let's say we have these random settings here. And if I wanted to turn this 4D, 3D, 3D, 3 on, I would turn it from a 0 to a 1. And then that would turn that setting on. Or let's say the hat wobble. Right now the hat wobble is on, but let's say I wanted to turn it off, so I'd turn that to a 0 and then it would turn off. So how do those settings apply? Well, in permissions for Unix or Linux, there's a series of settings that we have, either ones or zeros that we have. And so what does that look like? Well, first of all, we have three different levels here. First of all, we've got the user. So the file or folder, this could apply to files or folders. There's going to be some sort of user that's going to be attached to that, the owner of that file or folder. There's also going to be a group that's attached to that. And then there's going to be everyone else, that's not part of this group or not part of this user. So for instance, maybe we have a website and the file permissions on that website we want to make available to everyone else. Well, we would need to set it up that way. So what are the different permissions that we can get for each of these groups? Well, it's all the same. For each of these groups, it's all the same. It's read, write, and execute. So what are these? Well, read means that you could open up a file and read it. So I'd be able to take a file and open it up and be able to read that document or whatever the case may be. And then write means that I could actually modify that document. So I could go in there and add extra text if it's a text document. And then there's the execute. And execute is like if there's a program, being able to execute that program. Or if this is a directory, being able to just read what else is inside that directory. So for the user, maybe, this is the owner, so maybe we want them to be able to read, write, and execute anything that's in that folder. Perhaps the group level here, we want them to be able to read and execute that. However, maybe the rest of the world, maybe it's a website and we just want them to be able to read. So this would be the settings for each one of them then. A 1 means that it's turned on and available, that the user can read, write, and execute. The 0 means that they can't, so the group would not be able to write. I'm on my demo Pi here, and I just want to show you what these permissions look like on an actual machine. So this is a Linux, is what the base of this is. So I'm going to open up a terminal up here, and I'm going to just make this a little bit bigger. And then I'm going to list out the directory, what's in this directory. So I'm going to do an ls-l and hit enter. And let's take a look at this and see what this looks like. In fact, I'm going to even make it a little bit bigger here just so we got it, so we can see this. All right, so what do we have? Well, first of all, here are the permissions that we're talking about right here. And if it's showing you the letter, the RWX, that means that the permission is turned on. And if it's a dash, that means it's turned off. And what we see over here, demo Pi 42, that is the user. So that is the user for this directory right here, which is the directory is desktop. The second demo Pi 42 is the group. So it's a user and group by the same name. And so we've got demo Pi 42. So what is this telling us? What it's telling us is this first D means that this is a directory. So desktop is a directory, like a folder. And documents, in fact, all of these, there's Ds at the beginning of all of these. So these are all folders here, all directories. All right. So what can the user do? Well, the user can read, write, and execute. Those are all turned on. What can this group do? Whoever's part of the demo Pi 42 group can read and execute The dash here means that they can't write, that's turned off. All right, and then if they're not part of this group or not this user, what can they do? Well, they can read and execute. They cannot write because we see a dash right there. So these are the permissions. This is what it actually looks like on an actual machine. So what do these settings have to do with Octal? Well, if we want to make a change, one way that we can do that is by figuring out the Octal equivalent of what we want to change on these different files and folders. So what does that look like? Here we have the user, group, and other listed out. And for each one of these, we have the read, write, and execute for each one of those. And in this case right here, let's say we wanted the user to read, write, and execute. So we've got a 1 turned on for each of those. And the group, for the group, we want to read and execute for that. And everyone else, we want to block from them having access or being able to execute anything. So that's the settings that we want. Now, how do we then make this change? Well, we figure out what the octal is for this, because this is what the computer sees right here, but how do we actually make this change? Well, what we need to do is we need to figure out the octal equivalent of this. So in binary, it's a 1, 2, and a 4 here. So we've got the 4 turned on, so we got a 4, plus we got the 2 turned on, plus we got the 1 turned on. We add that together, 4, 5, 6, 7. So that is going to be 7 right there. That's the answer for that first number. The second number here, we've got the 4 and the 1 turned off, so 4 are turned on. So the 4 plus the 1 is 5. So we've got 5 right there. Then we've got the nothing turned on over here, so that's just 0. So if we wanted to have these as the permissions, then we would set the setting to 750, and that would implement this change. So what does this look like on our actual Linux machine? Well, let's use this folder music right here. So in this, we have, what is the current settings right here? The current settings, read, write, and execute is turned on for the user. So that would be 7, because that's 4 plus 2 plus 1, so 7. The read and execute is turned on for the group. So that would be 4, 5. 4 plus 1 is 5. And then same thing for the other. So that would be 7, 5, 5 is what it's set to, and we want it set to 750. So to change that, I'm going to do the command chmod. So that's change mode. And then I'm going to type in the number that I want, which is 750. So it turns off the read and execute for other. And then the folder that I want this to apply to, which is music, and I hit enter. And then I'm going to list out the directory again. And now we see that the read and execute is also turned off on the music. So we have now implemented that change. If I want to change it back, I'm just going to hit the up arrow here and change it back to 755, hit enter. And then we'll list this out again. And now what we see is it's back to where it was before. So that's how you would use the octal on setting the permissions of this machine.